Jai Hind, my dear students. So welcome to this lecture of Fundamentals of Mechanical Engineering and Mechatronics, which is code BME 101T in first semester and 201 in second semester. So in the last lecture we have discussed about the mechatronics and its evolution, its stages, phases and application in various fields. So in today's lecture we will discuss about autotronics, avionics, bionics, sensors and transducers. So first term and the sub branch of mechatronics is AUTOTRONICS. So AUTOTRONICS basically it is a combination of automobile plus electronics. So how electronics systems are embedded in mechanical system to make more efficient the automobile system. First electronic part in an automobile was called an ECU, that is engine control unit. However, analysts estimate that more than 80% of all automotive innovation now stems from electronics. Generally, if we talk about today's automobile system, then in new generation automobile system, 75 to 85% mechanical systems are embedded with some electronic devices. So, and new developments are coming very frequently in this field because it has no limit and the new electronic system are always developing. These are the elements, or you can say simply the application of autotronics system. So in an automobile, basically what we know that there are subsystems. Number one is braking system, steering system, suspension system, transmission system and engine and fuel intake. So earlier what was happening, and we have discussed it in our last lecture, that there were 4 phases of mechatronics. What was happening in our first phase of mechatronics? Basically all the mechanical system were being replaced by some electrical system. In second system, these electrically operated mechanical system were introduced with microelectronics. And in the third phase or third level of the mechatronics, there were another subsystem that is known as feedback system that makes system more efficient in controlling device. Next is, that is our current stage, is intelligent system. So the current level or current phase of mechatronics, that is intelligent system. We are talking about intelligent smart system. Basically these systems have self fault detection. This is the benefit of using any intelligent system. So now what is happening, these mechanical system, these are the part of any automobile system. These mechanical system now are being replaced by these electrically operated mechanical system, and also microelectronics and microprocessors were introduced in this system to make the system more efficient and more improved. Now first is braking system. Now braking system basically deals with the distance to stop any vehicle, that distance that any vehicle cover to stop any vehicle. So objective is to minimize this distance. Any braking system will be more efficient if this distance is very shorter. So now the various functions in ECB, or that we known as braking system, number one is anti-lock braking system, that is ABS. This is the very advanced technology in this field, and anti-lock braking system basically it is used in advanced automobiles to prevent slip and locking of the wheel as we apply the brakes on the wheel. Next is traction control system. So traction control basically is an active safety feature that helps to keep traction between the tires and the road in a slippery or dangerous condition. Traction is basically what? There are 4 wheels of any vehicle, but during any rolling, all wheels must roll along any similar curve and along the road with similar speed. But sometimes what happens, some of the wheels stop rolling and they performs any slipping action or any stoppage of the wheel. So prevent this, we need to improve this system by applying traction control system. In this system basically cut down that particular individual wheel which shows slipping and rolling action. This is the example of traction control system. This system shows without applying traction control system, and in this system basically we are using traction control system. You can see when all the wheels are rolling, but some of the wheels are performing slipping action. But in this way you can see if any wheel is performing slipping action, that we can cut down from the engine that particular wheel, and the rest of the wheels will continue rolling and they will go along this road. This is the advantage of traction control system. Next is steering system. So steering system basically it controls the applied pressure between the steering system and the hydraulic pump and the wheels of the vehicle. So there are advanced subsystems of steering, that is speed sensitive steering system, and another one is electrically powered steering. So in a speed steering system basically speed sensitive steering system is used to control the power steering pump pressure in relation to vehicle speed, that is below 16 km/h. This steering is basically computer operated steering. This action reduces the steering effort during low speed maneuver and parking. Now when we talk about electrically powered steering, that uses an electric motor to drive either the power steering by hydraulic pump or the steering directly. So as basically in this steering system an interface circuit, that same housing converts the signals from the torque sensor and rotation sensors into signal. The vehicle motion estimation controls uses the steering angular velocity that basically performs the information internally programmed with the particular system. Now next is our suspension system. So basically this suspension system is provided in any automobile vehicle to provide comfort to the passengers, that are comfort to the passengers. So in suspension system, in most vehicles on the road today are passive, as you know, and these shock absorbers help to dissipate the energy applied to the springs and damp to the oscillations. So if we talk about active roll control system, that is known as ARC system. So vehicles lean when cornering due to the weight transfer imposed by lateral acceleration. Factors contributing to the roll angle of the vehicle include vehicle height and suspension stiffness. There are some application in this system. The ARC system uses hydraulic and electronically technology to the vehicle roll and angle in cornering, which improves the handling. The active roll control system basically it consists of control module, accelerometer, speed sensor, fluid reservoir, electro-hydraulic pump, pressure control valve, direction control valve, a hydraulic actuator in both the sides, and the front and rear stabilizer bars. These are the basic components of any suspension system. Next is our transmission system. So then how the power is being supplied from engine to the vehicle, it is particularly managed by the transmission system. Mainly it controls the shifting process of the gears. Electronically controlled transmissions, that is known as ECT, were introduced on BMW products in 1986 on 5 and 7 series vehicles. So, the transmission control unit also adapts to changing condition within the transmission by monitoring slip ratios. The TCM controls the operation of the lockup torque converter, which further increases economy also, and there are some advantages of this system: increased fuel economy, improved shift comfort, increased driving safety. Next is electronic fuel injection. EFI system basically electronically meters the fuel so that the exact amount needed is provided to the engine. EFI uses to fuel the power to the engine by pumping it forcibly by using high pressure through a small nozzle or valve. Next, another feature of this system is airbags. The airbag technology is based on electronic sensor that measure the amount of quick deceleration through an accelerometer. The new calculation will take into account the position of the seats, that the use of seat belt and the weight of the occupants. Now, this is another sub branch of avionics, that is aviation plus electronics. When electronic system is introduced in aviation industry, then we call it avionics. The electronic system used on aircraft and artificial satellites and spacecraft, then we call it avionics. Avionics system include communications, navigation, the display and the management of all the system that are fitted to aircraft to perform individual functions. These are the elements of avionics. Number 1 is air conditioning system, aircraft fuel injection system, autopilot system, electrical power system. So, in air conditioning system, basically human body is unable to withstand the effects of a low pressure atmosphere. That's why the AC and pressurization system is a vital component of modern flight. And aircraft fuel injection system enables fuel to be loaded, stored, managed and delivered to the propulsion system in right amount that we actually require to run the aircraft. In autopilot system, an autopilot is a mechanical, electrical or hydraulic system that uses to guide an aircraft without assistance from the pilot. So, there are another subsystems of autopilot system, that is gyro, servo and amplifier controller. In gyro, basically it calculate the amount of rotation to sense what the aircraft is doing. In servo, to move the flight control surfaces. An amplifier basically increases the strength of gyro signals enough to operate the servos. A controller basically allows manual control of the aircraft through the autopilot system. Electrical power system, basically batteries are used for both aircraft startup and as an emergency source of power. In bionics, basically as the name indicates, it is the combination of biology plus electronics. So, when electronics is inserted in a biology field, then we call it bionics. Bionics, it is a science of constructing artificial systems that have some of the characteristics of living system. In other words, it is the application of biological methods and system found in nature of the study and design of the engineering system and modern technology. Now, if we talk about the principle behind the bionics, then it is seen in most of the cases that even if the body part is not working well, the part of brain responsible for controlling it works fine. As ideology, it believes that the signals from the brain could be extracted, deciphered and then implemented by the mechatronic prosthetic system. Generally, a mechatronic prosthetic system is interfaced to the biological body to overcome the disability. For example, here is the cochlear implant, which is implanted for hearing problems. A bionic ear or cochlear implant is designed to produce hearing sensation by electrically stimulating nerves inside the inner ear of the severe profoundly deaf patients. So let's have a look in the working of cochlear implant. So there are two systems, one is external system and another one is internal system in any cochlear implant. In external system it consists of microphone, speech processor and transmitter, while in internal system it consists of receiver, stimulator and electrodes. So what happens, microphone basically receives the sound and frequencies which process the speech by speech processor, acts on the frequencies received, it filters out the audio frequency, divides the filtered output in basically your and send to the transmitter. Transmitter further sends the channelized output to internally placed receiver. Then internal system basically it receives the signal transmitted externally. Stimulator basically it converts the signal into electrical impulses and sends them via internal cable to the electrodes. Electrodes basically they send the impulse to the cochlear nerve. This is cochlear implant, how it looks. This is external portion, this is internal portion. In external portion, microphone receives the signal, then it process. This is the processor of the battery, external transmitter, antenna and external magnet. This is internal, which is operated in the body, internal magnet, antenna and the receiver, stimulator and electrode which transmits the signals from sound receiver to the cochlear nerve. This how it looks. This is internal part and this is external part of cochlear system. Next we talk about sensors and transducers. So sensors are basically defined as a device which is used to measure a physical quantity, for example light, sound, temperature, etc. and basically it gives some output in an easy way to read format for the user. For example, a mercury thermometer, the mercury simply expands when the temperature rises to give a reading for the user. There are basically no electrical interfaces or changes. Thermistor also simply responds to the change in resistance due to the temperature change. So basically what a sensor is, it receives some signals from any external atmosphere and then it will give some output that we can read and we can understand by the frequency of this output. Now there are some different types of sensors: active versus passive sensor, digital versus analog, null and deflection, input and output configuration. So this is the sensor. Basically it is receiving some signals, then it is giving some output, it is sensing this signal. Now active and passive sensors. Basically in active sensor it requires some power source to operate, but in passive sensor no power source is required to give some output. In digital and analog sensor, main difference between these sensors, in digital sensor basically output is displayed in some numeric form, but in analog sensor it will be displayed by some pointer and in analog form. Null and deflection method, basically there are two methods to keep any pointer in a center. As if we talk about this is 0 pointer, then we can say it is in balanced position. When it gets deflected from this position, say it is 1, then we can say it is a deflection method. It is giving output by deflection. But in case of null method, if the deflection is represented by 1, then in another direction, another deflection in opposite direction will be treated as -1. That will bring your pointer in neutral position, that is 0, and your deflection will be null. So that's why we call it null method. Common sensors are thermistor, RTD, strain gauges, potentiometer, piezoelectric, thermocouple. These are the some common sensors. Another type of sensor is transducer. A transducer basically is a broader and it includes both sensors and actuators. A transducer can measure similar quantities to a sensor, but it will convert the signal from one physical form to another meaningful form, and meaning their input and output signals that are not the same as each other. A transducer basically it includes sensors and actuators. There are different types of transducers, input transducers and output transducers. As here you can see, this is sensor which is sensing some physical quantity, but in transducer what it does, it converts this input signal into some another energy of the another signal. Sensor is a device that when exposed to a physical phenomena, or you can say temperature, displacement or any other parameter can be there, produces a proportional output signal. Transducer is a device that converts one form of energy into another form of energy. There are another classification of transducer. One is input transducer and another one is output transducer. In input transducer, basically a sensor takes in physical energy and converts it into another output energy. While in output transducer, an output transducer or actuator takes in electrical signals and converts them into another form of energy, like a lamp converts electricity into light, and a motor on other hand converts electricity into the motion. Common transducers are load cell, resistive transducer, capacitive transducer, inductive transducer, strain gauges and LVDT. Application of sensors and transducers in different fields as position sensors, pressure sensor, temperature sensors, force sensors, vibration sensors, piezo sensors, fluid property sensors, humidity sensors. Basic difference between transducers and sensors: as in transducers it converts energy from one form to another, but in sensors it senses physical quantities and converts it into a readable form. And another difference between transducer and sensor is cable extension transducer, linear transducer and microphones are some example of transducers. But in sensors, if we talk about sensor, then thermistor, pressure switches and motion sensors are some example of sensors. Thank you.